Let me pull up the lecture. Not on the internet? It's not my day, is it? Oh, here we go. Okay, let's take this here. Main sheet. And today's the 29th. Okay, I renumbered the lectures so that today is lecture 1. The last one was lecture 0, so that it starts with lab 1. Okay, so as I always start the lecture with a little quiz. So here we have one. So now what we're going to do is go to Piazza. Go to piazza.com, where you've made an account for this course. And you'll have to give me a minute to put in the question. So all I'm going to do is make the choices that you can see on the lecture notes. And of course they just changed all this user interface. Ah. Hoo hoo hoo. I need to edit this one here. Good pull. I know it's a good pull. Come on, edit. Edit. Alright, now we have Fortress. Yes, these are probably not optimal spots to sit at, so that's perfectly good. Choose that. If you could log into Piazza and answer, and also look up this question here on today's lecture note and put in your answer real quick. Does anyone have trouble getting into Piazza? Why?
I just having trouble with the internet right now, so I have to leave that one.
I see. Yeah. Let's give it a couple of minutes, and if it doesn't shake itself off.
Yeah, I can't log on for some reason.
Okay.
My internet's working. I created an account last week, and it looks like my account's not even there anymore.
Okay. That one I might be able to debug. Okay, do you recognize yourself?
Yes, the third one is a tank.
Okay. You ready?
Oh, maybe I'm fine typing my first name.
Okay, anyone else having trouble getting into Piazza?
What's the question?
Sure. You can look at the questions yourself, and you really should. Point your browser to this URL here. Horstman.com, SJSU, Spring 2013, CS 185C, Lecture 01. Or simply navigate to the home page of the class and go from there. Because there's plenty of stuff that you will have a hard time reading on the screen, and it'll be much better to have it in front of you. Let's see how we're doing on our quiz. Okay, so I have 8 votes. There are 19 people in the room. Nothing will happen until I get them all in. Yeah?
I'm actually looking for night school.
Yeah. Did you put yourself in Piazza yet? Okay, do it right now. Do it right now. So go to Piazza. Go to the class page. You know where the class page is?
You kind of expected to at least review what has gone on in the first lecture. Okay, so then go to the page. You submitted the prerequisites? Well, then you are already in Piazza. One of the assignments is the prerequisite quiz. Want to put a screenshot of your Piazza of registration?
I don't know how the other.
You need to make it. You can't. Everyone else could. There's no mystery signing in the Piazza. You just make it a copy, sign up for the process. What may happen is that you accidentally sign up as an instructor. Then it'll reject it. But try again signing in as a student. Yeah?
What did I ask?
You mean you don't know how you answer? Did you submit it already?
No, that's it.
Well, that's pick your answer. You know what the questions are?
Yeah.
No, that's not the paper.
Yeah, okay. And now you put in an answer. Which one do you think is right? Yeah.
One for the customer.
You want to pick choice one.
Okay.
Is that what you want to pick? Okay, but why don't you first pick the answer and then you just click on it and then you click on submit.
Which one is true, right? Okay,
Anyone else? Has any trouble?
I'm just having general internet connectivity issues.
Okay. So you are.
I'm connected to the internet, but I haven't gotten through one of these interviews.
You're using the SJ. Would you mind using the Premiere?
I haven't set it up, but I would mind it.
Do you have something? That's the same password. Usually the Premiere is a little better.
Okay.
Give that a try first. That was Tom's Anyone else have any issues? Well, beat all issues to death today. It's going to go smoothly from then on.
You just okay?
Yes.
Okay, go and answer this question here.
I'm not connecting to the computer either.
I have just tried it. You using this little motor. actually worked okay in this room, but it's a good idea to like try it.
I was connected in the previous plan. It should be had happened.
Yeah. If it's a persistent problem, we'll get an extra problem. Yeah?
Can you minimize the gas again?
You can, what you should do right now, is go to this URL and read the stuff yourself. Because this screen is so dim, I've complained about it and said we need a new lamp. But apparently that's not in the budget. So you should just, just have the lecture notes on your laptop at all times. And then just use the faint image in front to help you along where, which slide we are. Yeah.
So I just put my answer in and then click submit.
I would think so.
Did you move the windows down so that I can...
What you want to do is you want to, and I'm purposefully obscuring it, I want you to open up a browser window to the slides so that you can see them on your own computer.
I think it's slow, or it's not loading. I think it's congested. Yeah.
Just right click on itself and whatever. Oh, see, this one's also trying to load the center.
Just turn on click on firstminute.com. So your website's on. It wasn't just for slide.
I mean, it would take a little bit of time because it's a large file and all the slides, but you got
It was working last night.
Right.
That's weird. Well, I'm just gonna read it.
Let me just for the heck of it, see if I can get... Yes, I think it's my website. All right, so we have 15 answers, and in the interest of time, I'm going to leave it here. So 10 of the 15 said... Okay, let's first of all go through. So should use the OpenJDK, not Oracle. So no one picked that, and that's just as well, because it's probably wise to use the Oracle JDK. I think that that OpenJDK will actually work, but why? It's yet another wrinkle in an already complex setup. So definitely use the Oracle JDK. Even on the Mac, the smart strategy these days is to just install the Oracle JDK. 1.7 doesn't come with anything else anyway, and just leave the Mac JDK to die the death that it has so richly deserved. So the second one, should you install Eclipse in your home directory and not in opt? The book does recommend that. Why?
Because you have permission.
So if you use Eclipse in more than one project, you tend to add different plugins into Eclipse. And the sad truth is that even though Eclipse is this great plugin architecture, that it is usually just a matter of time for these plugins to step on each other's feet. And so typically people actually download 2 or 3 Eclipses, use one for, say, I have 3 right now. I have one for Java EE, I have one for Android, and I have one for Scala. And in theory, I should be able to pack them all into a single thing. And if I had nothing better to do in my life than the care and feeding of my Eclipse instance, then that's what I would do. But in practice, it's much, much simpler to just have a different one. So that's why I put on a thing on Piazza yesterday, actually with the Android thing, don't even bother doing what the book did to install Eclipse and then install the ADT in there. Nowadays, Google has seen the wisdom of this, and they just give you a package that contains Eclipse and the ADT all in one bundle. since you're going to have a separate Eclipse installation anyway, you might as well use the one that's pre-integrated. And then install it in your home directory. It doesn't actually matter whether you install it in your home directory. You could install 5 Eclipses in some other spot, but the real point behind this is that you should not have a single instance of Eclipse, but you should have an instance of Eclipse per kind of project that you're doing. And that's maybe a little unfortunate, but on the other hand, it's a huge project. And thousands of people develop plugins for it, and the stability of it is not so great at this point. And this of course happens with any kind of successful plugin infrastructure, that after a few years it becomes a really unwieldy and unstable plugin infrastructure, and that's where we're at right now with Eclipse. So can you install the ADT into NetBeans or IDEA? That would be nice, but you can't. So it's tightly bound to Eclipse, and so that means that if you want to do Android programming with an IDE, then Eclipse is probably your easiest bet. There is a way of doing it with IDEA. I've never tried it, but they have an Android plugin themselves, and I'm not sure if it's part of their free or their commercial offering. If someone wanted to experiment with that and report back on Piazza, that would be wonderful, because Eclipse is okay, but it's not the perfect thing. Now, and 4, did anyone answer that? No. To run your app on your phone, you must first become a registered developer. For which phone is this true?
iPhone.
For the iPhone, right? Said you can't be an iPhone developer without first registering. The Android, on the other hand, anyone can do it, which is a great feature of that platform. All right, so at the beginning of every class, I'll have a quiz question or two to make sure that people kind of did their reading and that they're generally with it and present in class and all of that. The answers are public, so I can see, and anyone can see what anyone said, but I mean, there's no shame in a wrong answer. Every so often I'll put in a trick question, and I'll try very hard to get 20 wrong answers, and I'll see how close I get. So, let me close this poll. Moving on. So we're going to be starting with Android programming. It's by far the easiest platform to get going with. If you look at the latest numbers, Android has, 3/4 of the market share for smartphones at this point. And so it's this juggernaut that we definitely want to know how to deal with very well. Android is based on, at some point, on Linux. So your phone is a little Linux computer here. You don't normally see that as an Android developer. That part is completely hidden from you. You see it a little bit when you connect to it and you see a Linux file system in there. But generally, that's something that like a device manufacturer or someone who writes device drivers needs to know about. But we really don't. So as part of the Android platform is support for the standard hardware that you'll find on the phone, the camera, the GPS, the accelerometer, and of course support for the telephony, both the voice and the data bands, and for Wi-Fi. There is a custom 2D graphics library that they just wrote themselves to render the widgets quickly. You can do 3D graphics like for games, and that's based on OpenGL. And we'll do a little bit of game stuff, even though I know absolutely nothing about it. I've never played one on one of these things, but that's where you guys come in to help me out. And Dr. Pollard, who designed this course, says rightly so that programming games on these phones is a source of employment for many. So it'll be good to get into that. So now we can get to kind of the Java part of it. So there's a virtual machine that's not a Java virtual machine. I'll talk about that on another slide, called the Dalvik VM. And that's, as everyone knows, Dalvik is one of the major cities in the country of Iceland. And that's what's where the name comes from. I have no idea. One of the developers must have come from there, or his ancestors. So there's an application framework written in Java that is different from any other application framework that exists anywhere else, that we just have to learn it. And there are core apps that come with every phone. There's a browser, for example, on every app. There's a contact list on every app. And so it's possible, and in fact desirable, for our own apps to interact with the core apps that you find on the phone. So for example, it's possible to browse the list of contacts, provided that the user has given you permission. and use that in an app in some way. If it's a game, for example, then you can pick up the photo of the other player if that happens to be available, and so on. There's media support, both audio and video, including H.264. That's a patented standard for presenting video. And with audio, nowadays there's little issue in terms of open source audio. There may be some issues about MP3, but there's plenty of alternatives. Video is a nasty issue when it comes to an open source phone. So one of the things about Android is it's completely open source, and people don't have to pay any license fees to anyone. And somehow, and I don't actually know how that works, H.264 and its related video algorithms are patented. There is an organization that collects royalties for it, and maybe the vendors have to pay that to them directly. It would be interesting to find out. It's a nasty issue right now that there's really no true open source way of producing high quality video that can be delivered over the web. And finally, there's a little database in there using SQLite. It's a C-based database that's often used in Linux when you want to have a low footprint database. It's not like an Oracle-like database, but it's good enough to store relations just using regular SQL for your applications. Bit of history. Android is actually pretty old. I was surprised to see that it was founded in 2003. That's at a time when most of you were in junior high school, and it puttered along for a couple of years, and then Google bought it in 2005. Why would Google buy a phone in 2005, of which not a single one had ever been sold?
They know the market.
So what was Google worried about?
Apple.
They were worried, of course, about the iPhone, and what they were really worried about is advertising on phones. So their idea was, what's going to happen if everyone starts using phones a lot more than their regular desktop computers? Now, in 2005, that was actually not an obvious thing to think about, because the phones that were available at the time were generally fairly primitive, and it wasn't clear that everyone was going to use a phone. But they somehow saw that trajectory, and so they said, we'll have to do something. And so this just kind of as insurance, they bought that company. And in 2008, so this was another 3 years later, so they weren't working at a very fast pace, as you can see. Android 1.0 was released. And so Google had a reference phone, and so I remember seeing it. It was a truly wretched phone. It was slow, it was unattractive, it was heavy, and Apple was not exactly quivering in their boots. So they had come up with the iPhone in the meantime, which of course did extremely wonderfully, and it was a much nicer phone. And so but then in rapid succession, they started coming up with more and more versions. The original SDK was fairly primitive, so they kept expanding. Then you can see there's 4 versions coming out in 2009, another 2 versions in 2010. So that got us to the 2.3 release. That was kind of the standard on many second-tier smartphones for the last couple of years. It was very, very successful. So lots of cheap phones that you can buy today are still running Android 2.2 or 2.3, mostly 2.3. And perfectly good phones that cost a couple $100 maybe retail without the subsidy, and that are available worldwide. And then you can see how tablets started becoming obvious. With the iPad, Android needed a tablet story too. So they came up with this intermediate release, Android 3, that was for tablets only. And then in Android 4, they unified the tablet and the phone again, so that now you have the same OS on both. So does anyone have one of those Nexus tablets? So they're pretty nifty. For $200 you can get a 7-inch tablet. It's pretty nice, and it runs the same phone, the same OS as like if I have this the Nexus phone. I'm apparently a Nexus guy, and the Nexus tablet. They look like essentially identical, and it's pretty nice. So the advantage, by the way, of getting them directly from Google is that way you get the OS updates, and so for a developer that's a nice thing to have. And they're also completely unlocked, so you can muck with them any way you want. So if you wanted to have an inexpensive way of getting hardware for this course, you could just get a Nexus tablet, and you can do everything except making phone calls. And we're not really going to be talking about phone that much. So if you want an excuse to blow $200, here it is. So what about Android and Java? So interestingly enough, you use Java to write Android applications. And that was not totally novel at the time. The BlackBerry phone did the same thing. So BlackBerry, the old BlackBerry was programmed in Java. And of course there were plenty of feature phones, not smartphones, that had a micro edition Java inside. BlackBerry also licensed the micro edition Java, but then they put in their own application framework on it that was much more sophisticated than what you could do with a simple Java phone. The Java that Android uses is completely different from either the Java ME or from the BlackBerry application framework, so they just wrote it from scratch. And what they didn't do, though, was they didn't license Java from what then was Sun Microsystems, but they took an open source re-implementation of Java and called Apache Harmony, where open source developers had re-implemented a large subset of the standard library from scratch in a clean room without ever having seen the original source, or so they say. And so they've taken that and based their part on this open source library. That open source library had no particular condition attached to it except that any derivative of it also had to be open source. And so that again is another reason for the open source nature of all of Android. So as comparable in complexity to the BlackBerry framework, it does kind of similar things. It just does them in a different way. And then there's another thing that's very different, and that turned out to be important for legal reasons later. They did not use the Java virtual machine. So Java has a virtual machine that's second to none, certainly on the desktop and server space. So there's, at this point, probably no better commercial-grade virtual machine out there that can take bytecodes and optimize them on the fly. So what makes the virtual machine so great is that it'll execute your bytecodes, and then it sees which ones of them are worthy of being optimized, and then it compiles just those into something that goes very quickly. So particularly if you have any kind of long-lived processes, like on a server, that works phenomenally well, and the Java performance is generally better than anything that C++ can offer in that space. So these days, when programs get so complicated, the compiler does not know enough about a program. The virtual machine has all this extra knowledge that it can use to really squeeze out performance. But of course, to do that, that requires some amount of computing power for that optimization. Phones don't have that kind of computing power. The Java ME, the micro edition virtual machine, was generally not very performant, and so it was an easy sell for the Android people to say, we don't really need that virtual machine. We can do much better than that. And the first thing they did is they said, the class files are too big. And so they shrank the class files and made a different virtual machine that was specifically adapted to what a phone might need. That's this Dalvik VM. So you're programming in Java, but then the Java class files get on the development environment before you download them to the phone, get converted to some other virtual machine format. Now you never, as a programmer, care about the JVM instruction set, except if you happen to have a course where, like in a programming languages course, you might see a few of them. Or if you were a very sophisticated programmer and you generated bytecodes on the fly. That's once in a while you need to do that. But most application programmers don't care about the class file. So the fact that the class file now gets translated into something different, it doesn't really bother you. It did make a huge difference, though, a few years ago, no, a year ago. Oracle, which had bought Sun, sued Google, saying that Google had stolen all of their intellectual property. And the judge in the end said, you can't copyright a programming language, so they couldn't have stolen that. The implementation of Harmony was completely independent of the implementation of the library in the regular JDK, so they couldn't have stolen that. There was an issue. There were a few source files that apparently were copied, but there were like 10 files out of thousands, and so the judge said those files had never actually been used in there. That must have been some accident. And finally, because the virtual machine is different, the Java virtual machine is encumbered by a number of patents that the Dalvik VM circumvented, and so there was nothing for Oracle to to grab onto, and they ended up losing the lawsuit. It's an appeal, so it could turn around, but no one really expects that. So at this point, it looks like Android is free from that potential legal encumbrance. So a few Android buzzwords so that we can get programming and know what some of these things are. You're going to see activities, and so we'll have something called a main activity. That's just jargon for a user interface screen. So you should think of an Android application as being made up out of activities. Each activity consists of one screen. Then you sometimes might transition from one screen to another. There are many applications are single screen applications. A particularly simple one, but a more complicated one might have 3 or 4 or 5 different kinds of screens, each one of those called an activity. There's some transition between them. And so that's what most of the applications that are user-facing do. But there are other things that an Android app can have. You can have a service. Let's say long job without a UI. The classic thing is to play music or to download a bunch of stuff in the background. You would implement that as a service. So now you might have an app that has a few activities and a couple of services. Like if you think of a podcast player, the services would be to play the music, to download the music in the background, and the activities would be whatever it is that the user sees. You can install a broadcast receiver in your app. That's something that just sits there and listening for system events. So for example, if you wanted to listen to, like, again, a podcast player might be a good example. When you yank out the phone, the system event gets fired, and you might want to listen to that because then you might want to stop playing. I don't mean the phone, you mean the earphones. You know what I mean. When I take out the earphones, then a good podcast player would want to pause to see what happens. Or when the phone rings, for example, then the podcast player would also want to stop. So that's done with the broadcast receiver. Finally, an app can choose to be a content, to have a component that is a content provider that other apps can tie into. A good example for that would be the address book, where it offers services to other apps. And an app can choose whether or not it wants to be a content provider. Most of them probably won't choose that. So an app can have some of these components or all of them, and each component is a Java class. And there really is no entry point. There's no main. It's not like a top-down application like you might see in CS1. Like any graphical application, it just sits there and waits for services, waits for stuff to happen. So for example, when you start the application, a screen gets put up, and then your application just kind of sits there waiting for user interface events. One is, the other thing that's interesting, and I don't have that on the slide unfortunately, is that there's no particular way for an application to exit. And you know that as a user of an iPhone or an Android, you don't exit applications, right? They just all keep running all the time until eventually they get kicked out. So an application has to be prepared for the fact that it could be kicked out at any time when too many other applications are running. That's very different from like from a browser. You know, I could close the browser. There's no concept of closing an application on a phone. They just keep staying there. So of course that means it's the application's responsibility to deal with the fact that it might be closed at any moment, and also not to consume crazy resources when it's not actively facing the user. All right, the ADT, based on Eclipse, we talked about that, and there's also a set of command line tools. And today's lab we're going to be looking at the IDE, and in the next lab we'll look at the command line tools. So why have command line tools? Why not just have an IDE? The command line tools are there to answer a question as old as time. And that is, but why did it work on my machine? It must have happened to you in a group project that you and your partners had some issue where it worked on one fellow's machine and it didn't work on the other person's machine. And that happens all the time, because if you think about Eclipse or NetBeans, the number of configuration items in Eclipse or NetBeans are so vast that, and this is a little known fact, that the number of potential combinations exceed the number of atoms in the universe. So it is almost impossible for two people to have the exact same Eclipse configuration. And it's very, very common for nasty little things that you don't think about to make a build break on one machine and work on the other machine. So what one typically does this day and age is we say that building is too important to leave it up to the particular developer. when it ships the, when it has a build machine that checks out the code from version control, builds it, runs the automated tests, and then posts the results somewhere. And it keeps on doing that. So you typically want to have what's called a continuous build server that just keeps on building with no human hands in there. And that way you can accurately debug what any of these issues might be without getting into this, oh, he was running this thing on Windows 7 and Eclipse does this and all of that kind of stuff. So having the command line tools is very important as soon as you have a project that involves more than one developer. So what we will do is we will use Eclipse to sling codes, to get new ideas, to implement them, but then when the going gets tough and we actually want to build the product, then we'll use the command line tools for that. You have to be able to do both. The ADT, thankfully, runs on Linux, Mac, and Windows, so you can have any operating system that you want. Unlike the iPhone development kit, which requires a system from the same vendor. So use regular Oracle JDK. You could plug it into regular Eclipse, but like I say, you should just download the thing. It supports multiple SDK levels. That's kind of nice because, as you've seen on the previous chart, there's a dozen or so version numbers of the Android SDK, and so you want to be able to pick what you target. For the projects, particularly for the CineQuest projects that might actually go out there to real people, we target 2.2 because that captures 7% of the market right now. There's this nifty chart that shows, I think from 2 weeks ago. They update it every so often. And you can see how many users have which kind of system. So I must be one of these 1.2% here. And there's a whole bunch of people, my wife is up here, who still uses 2.2. So, but that spans 97%, and of course, as time goes by, it'll keep on going. So generally, we'll try to target 2.2, but right now for the homeworks and stuff, we'll just target whatever the default is. I think, I don't even remember. So also the ADT comes with something that you're going to learn to not like very much, the phone emulator. So that's the thing that emulates the phone. So it runs, it has all the software that a regular phone has, and so it'll take your applications and it'll show the applications. And it really it is a regular phone. It emulates it to an amazing degree, so it doesn't just try to recreate the phone independently, but it really has the exact code that runs on a regular phone. They want to get it as faithful as possible, so that when there are bugs, as there inevitably are, on the phone, that those bugs act the same way in the emulator to the degree that that's possible. The flip side of that is the emulator is dog slow. And so it simulates a CPU with actual instructions, and that simulation is not fast. And so many times you're going to be sitting there waiting for the silly emulator to load or to refresh itself, and you never quite know, is it your app that's dead or is it the emulator? So it is a really good idea to have an actual phone available as well, because when the emulator starts giving you flaky results, you can put the app on the phone. And that just takes a serial cable and some command line tools that we'll also discuss. So finally, we need to deal with version control. On any group project, you need version control. And so I've learned the hard way that if you first lecture for a few weeks, and then the group project starts in earnest, and you say, oh yeah, by the way, everyone is using version control, right? And here's the version control system, that there are some people in class who just until the very last week can't get their configuration for the version control straight. And so it becomes useless, and everyone still exchanges USB sticks and emails. And so I'm going to make sure that from the very get-go that everyone does have an incentive to debug their version control configuration. And that is, you submit all your homeworks and labs with the version control, and if it doesn't work, you're not going to get any credit for your homeworks and labs. And so that should be a powerful incentive for everyone to get the bugs out. So the reason, the version control system that we're using is Git. Not for any particular reason. It's not the most elegant one, but it is incredibly widely used. The Linux kernel, it was actually written for the people who write the Linux kernel. There's a website called GitHub that I'm sure you've seen that has 5 million projects and counting on there. Many of them, I'm sure, are half-baked student projects, and we'll add to that in this course. But they also have some incredibly useful projects out there, and we should be grateful that they host all of that stuff freely. For the homework and stuff, we're going to be using our own Git server that runs in some VMs somewhere in Kevin Ross's office. And that one is just a tiny little thing. But obviously, it doesn't do any good to put the homework out on Git where everyone can see it. So you may have used Mercurial in 46B. There's a lab in 46B that gives an introduction to Mercurial. Mercurial is like Git but sane, meaning that the Mercurial commands are very, very regular. And so in Git, there's crazy options that you just have to memorize. But if you've done anything with Mercurial at all, you'll just use Git, and the differences are pretty small. I'll go over them in a minute. If you've never used any distributed version control system, it does take a little bit of getting used to, because what you have to get used to the fact that the repository on the server, and then you have your own repository on your own machine, and your job is to put them into sync when it matters. So when you're in a team project, you want to put them into sync whenever your stuff builds. And into sync means that you pull down from what is already on the server into your system, merging any changes. That actually sounds scary to people because you know your teammates. Some of these teammates may be marginal. And so now they're putting code up there on the server. Now all comes down into your system. But as long as everyone is good about only uploading what actually builds and runs, it turns out that it's very rare to have nasty conflicts. And it's pretty easy to deal with it. And so the golden rule of using Git is you never do anything until you first pull down from what's on the server. Then you add your changes, and there's a couple of commands to do that, and then we'll play through in the lab, or as far as we get today. And then when you're done, you have to do a two-step dance, or actually three-step dance in Git. With Git, you first have to add any files that you might have added to the project. You then have to commit your changes, and then you have to push the changes back to the server. And you see the instructions down here. You'll be good if you use nothing but the 7 commands that you find on this list. 7, 8, whatever. And you should be able to do all your work with these 7 commands. There are a few things that make people unhappy with version control systems. And here is one. You get an error message that says, as these error messages usually say. You Google for the error message, which is what one does. You'll find someone in Stack Overflow saying, oh, if you just use this command, all will be well. Don't do it. Okay, don't use a command that you don't understand just because it's in Stack Overflow. It may well work, but it may also make a big mess. And Git is less, it's a version control system, so surely one can recover. But you can mess up Git pretty badly, so you don't really want to do that. If you get yourself in a situation where you don't know, put the question on Piazza, and we'll see how to get it clean up. And maybe eventually we will have to use one of those big bad commands, but it'll be after a couple of people looked at it. The other thing is sometimes Git, and Mercurial sadly too, foolishly says, oh, there's some conflict, just force it. Whenever you see that message, hands off the keyboard, deep breath, run for the hills. Do not ever force anything. There should never, ever be a reason to force anything. And so, I don't know why they give those messages. It's too bad. And finally, don't use a GUI client. Why not?
Hard to debug.
Yeah, and a GUI client is nothing but a front end to the command line tools. So the GUI client will, in rapid succession, spew out some of these commands, which may or may not be the ones that you actually want. And you don't really have any good way of knowing what they are. The GUI clients are written by happy day people. They work great when everything is happy. In those situations, you don't actually need the GUI client because you could perfectly well use the very simple command. But when things are unhappy, the GUI clients generally fail dramatically. they will issue the wrong commands very quickly and create a lot of damage in a very short amount of time. And it's very difficult to find out what they did because, you know, what happens behind the GUI that you don't really see. So there's very, very, very little reason to use a GUI client unless until you understand what goes on behind the scenes so well that you exactly know what happens when you push any particular button. And so we're not yet at, most of you are not at that point. So if you actually totally know what Git does in command line, then go ahead and use any GUI client you want. But until it gets to that point, just use the command line. The command line has the huge advantage that when something goes wrong, it gives an error message in text, and you can copy and paste that text and let other wiser people look at it. All right, so that's pretty much what I just said. What we're going to do today, and things will go badly, I know, we're going to clone the primordial repo for your homeworks and labs. And I said before, always run pull before you do anything else. You have to run add to add new files. So anytime you add it, you come up with a new file. That's going to happen a lot in the first few lectures and labs. Eventually, the add part is pretty much over because you just keep on refining what you already have. And then it's easy to forget to add. Then you're going to have to run commit with a -a flag, which is unfortunate. Just do it. That's how commit works. Like you always use -a, you always use -m with a message. I'm not particularly about the message. You're supposed to use an informative message. In many cases, I'm sorry to say, my informative message is period, 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 and I think that's okay. And then finally, you need to push it, and that's again where Git is a little bit crazy in that the exact way that you push it depends on whatever, and so this magic clause will work for us to save. Now, a big thing with version control, where it's also dangerous, is you must be sure not to put junk into version control. So you should only push those files that are actually part of your source. So for example, you would never want to push a class file. That class file can be regenerated. There's no need to clutter up the space. You should never push anything, and that's more serious, that has anything platform dependent in there. So if something says /users/chi, people would hate me if I pushed that, right? Because then when they pull it, then they get their configuration file overwritten with something that says /users/chi. So anything that's dependent on any personal settings or something should never be checked in. And there's a file called .gitignore that you're going to be building in this lab that lists all of the files and file patterns that should not be checked in. If accidentally you did check one of those in there, then you can, what can you do? That would be a good time to put a question into Piazza, because then I would have to figure out exactly how to do it. You have to remove it, but of course you still want it locally. You have to add it to gitignore. You have to put it back, and then it'll work. All right, we'll practice this for a couple of weeks so that it becomes second nature by the time that we need it in the project in earnest. And so, like I say, eventually in the project, the project will always be built on a machine that's not your own by checking it out from version control. And so it's important that you get your stuff in there, otherwise nothing will get built. So in the labs, we'll have a lab in every class. Hopefully I won't be talking quite as much all the time. So the lab is supposed to be like 45 minutes long. Today we're barely going to get 20. So we'll pick it up next time. And so you bring a laptop, you do it in pairs. Today we'll just have some impromptu pair assignments, and I'll tell you in a minute what the pair assignment is. So let's do this step here individually, and that'll determine the pair assignment. So what I want you to do is clone the repo that was made for you, which is empty, by putting in this very command in here. So copy and paste it into your command shell, except change last name _ first name into the exact same last name first name that you used when you sent in the prerequisite request. Remember, you submitted a file that's last name first name .pub. That's the exact last name first name, but not the .pub. So go to your home directory, put in this very same command. So those of you who are running Windows should do this from inside their Linux virtual machine. I'm going to try it myself. if you already happen to have a directory called CS185C, you'd need to move it first. I hadn't thought of that. Or give this one a different number, a different name. It worked. Mine is called, because I did this before coming up with the last name, first name convention. So you would just put in your last name, first name here.
And it's supposed to be empty, right?
Yes. Yes, so in fact what happens, the answer that you'll put in your lab report was, it said it was empty. Now I've given away the secret. So, so who's gotten this to work? Okay, so I want to show of hands of everyone who's gotten it to work. 1, 2, 3, 4. Who's gotten this command to work to the point that it checked out the repo? 6? Okay. 7. Okay, we need to go up to 10 because we're 20 people in here and we need to team up those who've gotten it to work with those who haven't. This may not be a good way of building teams of equal competence. Yeah?
The password is...
If it asks you for a password, then you did not give me the right key or your key is misinstalled or something. So it should do it without asking for a password. There is no password. Otherwise we'll need to debug what it is. Okay, anytime that it asks for a password, it means it did not work. Alright, so let's see, it worked for you?
Well, you asked me for a password, but I put in this, one that I used, I think for the RSA key, and it worked.
Oh, that's okay. I take it all back. If it asks you for a key password, that's great. That means you were better citizens than I am and made your private key with a password. No, that's great. Go for it. So if in that case, then if it came down, that means it worked. If, on the other hand, the Unix system on the other end asked you for a password, independent of the key password, that means it did not work. So if you have a key password, that's wonderful. Maybe I should get rid of that habit myself. Then that's great. So yours worked with the key password.
Yeah.
Did yours work? Okay, your buddies for today. Did yours work?
Not connected to it.
Did yours work? Did yours work? Okay. Did yours work? Okay, did yours work? Yeah. Okay. Then the two of you can be buddies for the day because we only need one that worked. Yours work?
No, I didn't see my key, that's all.
Okay, we'll deal with that. Did yours work?
Yeah.
Okay. Did yours work? Did yours work?
No, I'm doing the key.
Did yours work? Did yours work? Okay, then the two of you can be buddies. Did yours work? Huh? Okay, you haven't done the keys? Okay. Those of you who have a buddy can just get started with the last. Did yours work? Okay, yours? What's that? Okay, did yours work?
No.
Does yours work? You just said ask for a password. Did yours work? And what password? Did you have a key password? Did you make a password for your password? Okay. Did yours work? Okay. Well, I guess then let's do the following. Let's not do the lab. We'll just defer the lab until next, until Thursday. And I'll just be Dr. Git for the rest of the day and figure out what might have gone wrong with everyone's machine. So those of you who got the stuff right, you just can go and have an extra 15 minutes of your life, and everyone else needs to queue up here and I'll have to look at their machine. Okay?